Welcome to the deep dive. I'm genuinely excited about today. We're diving into some of the most, well, challenging ideas in science.
Absolutely. Prepare to have your reality stretched a bit.
Yeah, definitely. We're exploring the universe's wildest theories, things like the multiverse, quantum entanglement,
The simulation hypothesis?
and black holes possibly being portals. I mean, stuff that used to be pure science fiction.
Exactly. But now it's serious scientific inquiry,
Yeah,
just like quantum mechanics was, or relativity.
right. And today is August 26, 2025, and these ideas are really buzzing in the scientific community.
They really are.
And hey, before we really jump in, a quick heads up. If you're hooked on gaining knowledge like this, you absolutely need to visit Mind Expansion Daily.
Oh yeah, great resource.
It's incredible for staying informed and expanding your horizons. While you're there, please hit that like button and subscribe to Mind Expansion Daily. It truly helps us grow and reach more curious minds worldwide.
It really does make a difference.
And if you're really loving the insights we're sharing, maybe consider buying us a coffee. There's a link for that right in the description.
We'd appreciate that. Okay, so our mission today,
Right, the mission.
we want to pull out the key nuggets from these audacious ideas, help you grasp not just what they are, but why they matter, why they're important for understanding, well, existence itself.
It's like watching science evolve in real time, isn't it?
It really is. What
Yeah.
sounds completely wild today could be foundational tomorrow. You never know.
Okay, let's unpack this first mind bender. The multiverse. It sounds like something straight out of a comic book, seriously. But what's the actual theory proposing?
Well, the core idea is that our universe, it's just one of countless other,
Outlooks.
potentially countless. And crucially, each of these other universes could have totally different physical laws, different constants.
So not just like small historical differences, but fundamental physics being different.
Exactly. Think about its roots. It connects to things like string theory.
Those tiny vibrating strings.
Yeah, those. And also inflationary cosmology. The universe expanded incredibly fast right after the Big Bang.
Uh-huh.
Alan Gust's work back in the 80s suggested that this inflation process could have actually spawned multiple bubble universes. Not just one Big Bang, but maybe many.
Wow. Okay, so how many are we talking? Is there like an estimate?
Well, physicist Brian Greene threw out a number.
Yeah.
It's staggering. 10 to the power of 500.
Wait, 10 with 500 zeros after it?
That's the one. An almost unimaginable number of universes, each potentially unique. Different dimensions, maybe gravity working backwards.
That's incomprehensible. Is there any hint of this in our universe? Any evidence at all, or is it just math?
It's mostly theoretical, but there is some indirect, let's say, circumstantial evidence people point to.
Hmm.
We look at the cosmic microwave background radiation, the CMB.
The Big Bang's afterglow, right?
Exactly. And there are anomalies in it, specifically these unexplained cold spots.
Close up.
Yeah, areas slightly cooler than expected. Laura Mersini-Houghton, for instance, argues these could actually be like bruises, imprints left over from collisions between our universe and others.
Collisions between universes. Okay, now my head's really spinning.
And data from the Planck satellite in 2024 seemed to strengthen those claims a bit. But, you have to be careful.
Right. What did the skeptics say?
Skeptics argue it's probably just statistical noise in the data, random fluctuations that look like a pattern, which is, a perfectly reasonable scientific counterargument.
So the multiverse idea, it's not just about other places existing. It kind of shakes up our whole idea of uniqueness, maybe even causality.
It absolutely does. It redefines space, time, possibility itself. If there are infinite variations, infinite versions of you making different choices, yeah, it's mind-boggling, but mathematically plausible.
Okay. Moving on to something Einstein himself found disturbing. Quantum entanglement. He called it spooky action at a distance. That sounds skeptical.
He was definitely skeptical. He felt it violated the cosmic speed limit, the speed of light.
So what exactly is entanglement? Give us the nutshell version.
Okay, imagine you have two particles, say, electrons. You link them in a special quantum way. They become entangled
Linked how?
so that their properties are connected. For example, their spin. If you measure the spin of one electron and find it's up, you instantly know the spin of the other one is down.
Instantly, even if they're miles apart or light years.
Instantly.
Yeah.
Regardless of distance. That's the spooky part that bothered Einstein. No signal seems to travel between them. It's just
Yeah.
connected.
Has this been proven? Or is it still just a weird theoretical thing?
It's been proven. Repeatedly. The first real demonstrations were back in 1972 with Bell tests experiments designed specifically to test this,
Oh.
and the Nobel Prize in Physics in 2022 was awarded for experiments that confirmed entanglement over significant distances, like 12 miles. So, yeah, it's real. It's a fundamental part of quantum mechanics.
12 miles. That's pretty far for an instant connection. How does that work in practice? The electron example was good.
Right, the spin example's classic. Measure one, know the other, instantly. It just happens. It really challenges our classical intuition about space and separation.
Are there new developments pushing this further?
Definitely.
Sure.
There was a study in 2025, just this year, where scientists managed to entangle particles between Earth and a satellite.
Earth to orbit. Wow.
Yeah, a huge step for things like quantum communication. Imagine unhackable networks based on these instant private connections.
So it's not just weird physics, it has actual applications.
Huge applications, especially in quantum computing. Entangled quantum bits, or qubits.
Qubits, right?
They can hold multiple states at once. Because of entanglement, you can link them up to perform calculations that are, potentially millions, maybe billions of times faster than our best classical computers. Think drug discovery, material science, breaking encryption.
Revolutionizing AI, maybe?
Potentially, yes. It hints at a deeper reality, one that's fundamentally non-local, interconnected in ways we're only just starting to grasp and utilize.
Okay, deep breaths, everyone. This next one. It might trigger an existential crisis. The simulation hypothesis.
Ah, yes. Are we living in a computer program?
Basically. Are we all just lines of code on some cosmic hard drive? Where did this idea come from? It sounds like the Matrix.
Well, it has serious philosophical roots. It was proposed formally by philosopher Nick Bostrom back in 2003.
Bostrom, okay. And what's his core argument? It's not just, hey, maybe this is fake, right?
No, it's more structured than that.
Yeah.
Bostrom argues that if any civilization, anywhere, reaches a post-human stage, meaning they have immense computational power.
Like way beyond anything we can imagine now.
Exactly. Then it's highly likely they would run simulations, lots of them. Ancestor simulations, simulations of other possible realities, who knows?
Okay, so they could run simulations. Why does that mean we're likely in one?
It comes down to probability. If you have potentially billions, maybe trillions of these simulated realities being run, and only one base reality, the original, unsimulated one, what are the odds that we just happen to be in that single original reality?
The odds seem pretty slim, put like that.
Bostrom estimated maybe 1 in a billion, or even lower. Statistically, it becomes much more probable that we're living inside one of the simulations.
Okay, that's unsettling. Is there anything in physics, anything observable that hints at this, even speculatively?
There are some intriguing points, though nothing close to proof. Some argue that the universe having fundamental limits, like the speed of light, kind of resembles computational limits, like the processing speed or the pixel resolution of the simulation.
The universe has a maximum frame rate.
Sort of, yeah. And quantum mechanics itself, the way things seem probabilistic, only becoming definite when observed, some say that mirrors how game engines or simulations might render things only when needed to save resources.
Interesting. Any recent research?
There was some MIT research mentioned in 2025 suggesting our universe's entropy, its tendency towards disorder, aligns mathematically with what you might expect from a coded informational system. Again, speculative, but interesting.
So who buys into this?
Yeah.
And what are the main criticisms?
Well, high-profile people like Elon Musk have famously said that they think it's highly probable, like 99.9% chance we're simulated.
Wow. He really went there.
He did. The main criticism, though, is pretty fundamental. It's unfalsifiable.
Meaning you can't prove it wrong.
Exactly. How could we, from inside the simulation, ever design an experiment to definitively prove we're not in one? Or that we are. We can't step outside the system to check.
Right. It remains a philosophical puzzle then, mostly.
Largely, yes.
Why?
But it forces you to ask profound questions. If it's true, what about free will? Is it real? Or just part of the program? What's our purpose? What does real even mean anymore?
Yeah, definitely one to ponder late at night. Okay, final theory. Black holes. We know they're cosmic monsters, incredibly dense, inescapable gravity.
The ultimate cosmic vacuum cleaners, essentially.
But could they be more? Could they be portals? Gateways?
That's the really wild idea. Black holes are regions where gravity is so strong, nothing, not even light, can escape once it crosses the event horizon, the point of no return.
And at the center is the singularity, right? Where physics breaks down.
Precisely. But the theory we're discussing, explored by Stephen Hawking, Kip Thorne, and others, is that maybe, just maybe, They aren't just dead ends. Maybe they're gateways.
Gateways to where? Other dimensions, other universes.
Potentially either or both. Or even just shortcuts to distant parts of our own universe. The idea often involves something called a wormhole.
Wormholes, like in sci-fi, tunnels through space-time.
Exactly. Hypothetical tunnels, shortcuts through the fabric of reality.
Yeah.
Imagine folding space over on itself.
Okay. Is there any research supporting this, or is it purely theoretical speculation?
There's theoretical work and simulations. For example, simulations in 2023 suggested that certain types of rotating black holes might theoretically stabilize a wormhole, keeping it open.
Keep it open long enough for something to pass through.
Potentially. And remember the Event Horizon Telescope image from 2019? The first picture of a black hole's shadow?
Yeah, that was amazing.
While it didn't show a portal, obviously, it confirmed our models of gravity in these extreme environments are on the right track. It boosted confidence in the theoretical framework that allows for things like wormholes connected to black holes.
But could a person actually travel through one safely?
Almost certainly not. The tidal forces near a black hole, especially a smaller one, are immense. They'd stretch anything spaghettification, they call it, long before it reached the singularity or a potential wormhole opening.
Spaghettification, lovely. So no interstellar travel via black hole anytime soon.
Probably not for matter or people, but maybe. Information. Stephen Hawking's later work, his soft hair theory from around 2016, suggested that information isn't actually destroyed when it falls into a black hole.
It's not lost.
It might be encoded on the event horizon in some subtle quantum way, so maybe information could traverse, even if physical objects can't.
So even if we can't use them, the idea that these portals might exist dramatically changes how we think about space-time.
Absolutely.
Yeah.
It hints at possibilities, maybe multi-dimensional realities, cosmic shortcuts, whole new realms of existence beyond what we currently perceive.
Okay, so we've covered the multiverse, entanglement, simulation, black hole portals, a seriously wild ride. What's the big picture here? What do all these mean for us, and how do they push science?
Well, the implications are profound, aren't they? The multiverse challenges our place in the cosmos, maybe even our free will, if all choices play out somewhere.
Right.
Entanglement shows reality is interconnected in ways that defy common sense, opening doors for instant communication, powerful computing.
It's a simulation that forces us to ask what real even means. Existential questions galore.
And black hole portals suggest the structure of space-time itself might be far more complex, maybe traversable in ways we can't yet imagine.
And these aren't just thought experiments locked away in universities, right? They actually fuel real research.
Absolutely. The multiverse idea directly influences how cosmologists analyze the CMB data, looking for those potential collision signatures with things like the Simons Observatory. Entanglement research is the driving force behind quantum computing, like Google hitting that 100-qubit coherence mark this year. That's entanglement in action. Studying black holes with tools like the James Webb Space Telescope helps us test the limits of gravity, refining theories that might eventually incorporate wormholes or extra dimensions.
Even the simulation idea has practical offshoots.
In a way, it inspires research into the fundamental nature of information, computational models of consciousness, the ultimate limits of what can be computed, which ties back into the basic laws of the universe.
It really makes you wonder, how often do these out there ideas actually become mainstream science?
It happens more often than you might think. Remember, heliocentrism, Earth going around the sun. That was radical, even heretical, in the 17th century.
Good point.
Or quantum mechanics itself in the early 20th century. Einstein famously disliked its implications. Now, something like 90% of physicists accept it as fundamental.
So where are we with these theories now, acceptance-wise?
It varies. Surveys suggest maybe 60% of physicists think the multiverse is plausible, even if unproven. Entanglement is experimentally confirmed fact. The simulation and black hole portals are much more speculative.
But people are fascinated, right? I see this stuff discussed online all the time.
Oh, absolutely. Public fascination is huge. You see posts on platforms like X, multiverse confirmed, getting thousands of likes, even if the science isn't quite there yet. It captures the imagination. I remember when I first really got entanglement. It just changes how you see connections.
But there's pushback too, right? Healthy scientific skepticism.
Of course, and that's crucial. The multiverse faces criticism, like from Sabine Hossenfelder, for being potentially untestable. If you can't test it, is it really science?
A fair point.
Entanglement has practical hurdles, like decoherence. Keeping those quantum states stable is hard. The simulation, as we said, is likely unfalsifiable. Black hole portals are pure theory right now.
So the challenges remain.
Yes, but those challenges are exactly what drives innovation. They push scientists to invent better telescopes, quantum satellites, gravitational wave detectors, to find new ways to probe these mysteries.
What an incredible deep dive we've had,
Hmm.
honestly. From infinite realities to maybe living in code, the universe is just consistently weirder than we imagine.
It really is. Multiverse, entanglement, simulation, black hole portals. Each one pushes the boundaries.
So what's the final takeaway? So what for someone listening?
I think the takeaway is that these theories, even the most speculative ones, are vital. They expand our vision of the possible, they force us to question our assumptions and drive the engine of scientific discovery forward. They remind us there's always more out there.
Yeah.
Our reality might be far, far more complex, interconnected, and maybe even more exhilarating than our current understanding allows. For me personally, entanglement is the most exciting right now.
Because it's being applied.
Exactly.
Yeah.
Because things like quantum communication, maybe even a quantum internet, are starting to emerge from it. We're seeing glimpses of that non-local reality actually being harnessed. It's not just theory anymore.
That is pretty amazing. So for everyone listening, after hearing all this, which of these wild ideas grabs you the most? What do you think is the wildest possibility out there?
Which one feels closest to being proven, maybe?
Yeah. Keep questioning, keep exploring, and join us next time for another deep dive into the fascinating world of knowledge. And please don't forget to visit Mind Expansion Daily for more incredible insights like these.
Definitely check them out.
And if you haven't already, hit that like and subscribe button. It really does help us reach more people. And if you feel like it, the link to buy us a coffee is right there in the description.
We love hearing from you too.
Oh, absolutely. Tell us in the comments, do you agree with our take? Disagree? What stood out to you from this deep dive?
And where are you listening from? We're aiming to grow worldwide.
Yes. Drop your location in the comments. It's amazing seeing our global community connect. We can't wait to hear from all of you.